We would love now to transition to our next award, which is the very important Dr. Otto Bayer Award. Again, let's start the video and we'll get that started. Thank you.
I strongly believe in serendipity. Yeah, I'm Frank Glorius. I'm a professor for organic chemistry at the University of Münster, and I am a researcher and I also am a teacher. I always like to point out that we know about molecules. Molecules are the smallest particles everything is made of, and in my work we try to make molecules in a more efficient manner, which is good for a sustainable future. We work on many different research areas, and one of the areas is machine learning for chemistry. So the students that work in this field in my group work a lot on computers, but from time to time they also go to the lab and run reactions to produce data. We also do reactions under high pressure. For our hydrogenation reactions, we have to use reaction vessels that tolerate this high pressure. These are steel autoclaves that tolerate up to 200 atmospheres of hydrogen. And great inspiration for me is research itself. So I really am a wholehearted researcher. I love to think about new ideas. I love to interact with other researchers. But a great motivation for me is also to work with students and that we can guide them basically through the world of science and chemistry. Actually, there are many challenges. So I work on many different research areas, and I think in each of them we really try to tackle the most important problems. For example, in the field of arene hydrogenation, we really try to come up with a general catalytic system that allows us to produce valuable products. Receiving the Otto Bayer Award is a really great honor. Otto Bayer himself was a pioneer of science. For me, it shows me that my work is recognized, and it is also a great honor for my students as well.
Sustainability is achieved when the needs of the present can be satisfying the needs of the future. And that's actually not a statement of a United Nations representative, and it's neither a line taken from a political program. Sustainability is achieved when the needs of the present can be satisfied without compromising the needs of the future. That's actually the first line of a very recent scientific paper of today's Otto Bayer awardee, Frank Glorius. He published that recently in a journal of the American Chemical Society. Our prize winner, however, is known for creative organic chemistry. We just heard it. So how can he think about sustainability in such a way that he puts a first sentence in an important paper on that topic? What is special about his approach? How does he envision the future of chemistry? I think to understand this, we first have to recall how organic chemistry actually works traditionally and also largely today. Roughly speaking, there's three major steps, right? We start with huge amounts of fossil fuels, coal, oil, gas, and then we fractionate the ingredients and obtain basic compounds such as methane or benzene. And then these basic compounds are diversified, they are functionalized, and this is generally a multi-step process. Often it's a very complicated process, also an expensive one. And as a result, we then obtain many different substances, a variety of chemicals such as polymers, pigments, or drugs. And without these chemical products, our modern world would simply not exist. There would be no advanced technology, there would be no functional clothes, there would be no modern medicine. However, these chemical processes are often not sustainable, and they can have a major impact on the environment. And many scientists, therefore, work on enabling a transformation process in chemistry. Over the next decades, fossil fuels may be increasingly replaced by biomass and recycled materials. As a consequence, the fractionation processes also will have to be different, and the synthetic routes to obtain the chemical products we need will also change. This transformation of chemistry is a historic challenge. It will keep generations of chemists quite busy. However, it promises less exploitation of resources, less energy consumption, and also less waste production. Our awardee is one of the pioneers of such green chemistry. Like other outstanding scientists, he chose his topic very wisely. His long-standing interest is the mild activation of carbon-hydrogen bonds. You can use such bond activation to selectively add a chemical group to a molecule and make a new compound using a different and much milder route. This can make organic synthesis not only more sustainable but also more economic. By reducing the number of synthesis steps, the consumption of energy, and the waste of scarce and often precious metal catalysts, these are also reduced. I want to give you an example. In a recent breakthrough, the team of Glorius, together with his American collaborators, was able to activate bonds using light. As they described in Science in 2021, they could produce complicated molecules using a sustainable route. In particular, they used light as the energy source to convert a basic flat organic compound, an aromatic compound, into a sophisticated three-dimensional molecule. Just briefly for the experts in the room, quinolines and quinasolines, which often have reactivity problems, could be coupled using alkenes using light-mediated cycloaddition. So what is important to realize here, you can see it using that example, but also more generally, the new methods that he invents are not only mild, saving energy, solvents, and waste, they also enable more chemistry than before. The methods expand the range of molecules that medicinal chemists can use during their search for new drugs. It sounds amazing. Sustainability does not necessarily compromise chemical possibilities. It can enlarge them. What does it need to be so creative? A possible answer Frank Glorius actually gave by himself. He sees it as a big advantage, and now listen carefully, to throw his original plans overboard. Indeed, that's what he said. Science is an argument we have with nature. Or, as Frank puts it, we are in the laboratory, we ask the questions, but nature gives the answers. But once again, how did our awardee become so creative? I think it certainly helped him to move around. He studied chemistry at Hanover and Stanford University. For his doctoral research, he worked at the University of Basel and the Max Planck Institute für Kohlenforschung in Mülheim. After obtaining his PhD in the year of 2000, he spent several years as a postdoctoral fellow at Harvard University. He then became an independent researcher at the Mülheim Institute and later an associate professor at the University of Marburg. And since 2007, he served as full professor of organic chemistry at the University of Münster. For his outstanding research, he obtained many awards, the Leibniz Award, the Gay-Lussac-Humboldt Award, and also 2 grants of the European Research Council. But in addition to his research, Frank Glorius is teaching and training the next generation of chemists. He was named Hochschullehrer des Jahres in the year 2019. And he's actually very famous for his Christmas lecture. If you have a free evening, I recommend you watch that lecture. It's available on YouTube. The chemistry students at his home university liked him so much that they gave him a prize. I forgot the name, it's a funny name, a prize that they give out at the University of Münster. He really takes care of the next generation. For example, he organized a meeting called Rising Organic Chemists in Catalysis. You can already see his attitude, right? It's about, fostering young people, make them feel valuable and also to support them in what they want to do. What is there yet to come? Recently, Glorius initiated a new program of the German Research Council on, we just heard it, molecular machine learning. You all know that machines are now able to learn. We're all familiar with this. Machine learning is the basis of speech recognition, email filtering, or automated image recognition. You want to find all the photos of your partner amongst the 10,000 photos on your phone? No problems. Machines have learned how to do that for you. Or if you want to travel to a new country, no worries, because machines have learned to translate for you. But what is molecular machine learning? Actually, Frank has organized an international symposium on this topic only a week or two ago. His idea is that machines not only help researchers in planning complicated organic synthesis protocols, but also that they accelerate the transformation to green chemistry in various other ways, eventually to allow us to predict the best routes to new sustainable chemical products. And I'm sure he will tell us more about this in his lecture that is yet to come. When you hear about all these activities, you may wonder where Frank Glorius takes all the energy from. It's likely that his passion for science, that he once said he has, but also his co-workers share, plays an important role. He actually knows that he cannot share his passion. He has to evoke passion in others. Or simply put, he knows that he wants to build a ship that sails to new horizons. And this is why he teaches his co-workers the passion for the sea. Dear Frank, we wish you all that passion, and we wish that it lasts for a very long time. And we hope you and your creative team can contribute much more to the development of such green chemistry. Many congratulations on receiving the Otto Bayer Award today, and all the best to you personally, your partner, your whole team. All the best for the future. Thank you very much. Gratuliere. Alles Gute. Jetzt müssen wir aber noch stehen bleiben und du müsstest das so halten. Ich kann das ja halten.
Teamwork.
Okay. Ich leg das hin, dass du die Vorlesung halten.